is a quadratic. We're told that it's a quadratic right at the start, where they give us the equation of the function. And we're told where the vertex is. So this is the lowest point. The word vertex just means minimum point. We're also told that it intersects the x-axis at these two different points, so 2, 0 and p 0. And the first thing we need to do is to find the value of p. Now we know that all quadratics are symmetrical, which means that this point here lies directly in the center of the quadratic parabola or curve. So if this is 0.5 on the x-axis, then that tells us that this distance here is a distance of 2.5, which means that this distance has to be exactly the same. So 2.5 plus that 0.5 gives me the value of p, which is therefore 3. So p equals 3 is the first part. It's just 1 mark, and that's for the answer. And then for the second part, you would get follow-through marks should that be incorrect, but you had to find the value of a, b, and c in the equation. For this, you have 3 coordinates that they've given to you in that graph. So minus 2, 0, 3, 0 that we now know from the p, and then the 0.5 minus 12.5. So we can actually create 3 sets of simultaneous equations. So the first one is using that coordinate of minus 2, 0. So that's the first coordinate, which means that when y is 0, x is minus 2. So I'm just subbing in minus 2 into my general form and the coordinate point of 0, minus 2. Now I can rearrange that, make it a little bit better or simplified. So that's just 0 equals minus 2 squared is 4. So 4a minus 2b plus c. And now I'm going to do the same thing again for my next coordinate, which is the one I found with p, 3, 0. So this time 0 is equal to a 3 squared plus b times 3 plus c, or 0 is equal to 9a plus 3b plus c. So all I'm doing between here and here is just simplifying it down. And then the last one, I have the coordinate 0.5 and minus 12.5. So negative 12.5 is the 0 or the y value, and then I'm substituting in a and then 0.5 squared plus b 0.5 plus c, and that's going to give me 1/4. So 0.5 is a half, and then I'm squaring it. And if you weren't sure, you could actually just type that into your calculator. So in your calculator here, you can just have 0.5 squared, and you can see there it's 1/4 of a plus 1/2 of b plus c. And that is not equal to 0, sorry. That is equal to negative 12.5. And now we can go to our calculator. We can do apps and polysimul 2 and simultaneous equation solver. We have 3 equations and 3 unknowns, and we're going to go into next. And then here we just type in the equations we found. So for the first one, I had 4x. Now obviously they call it xyz, we have abc, but it's the same thing. Negative 2 and 1c, and that equals to 0. And then the second one is 9a, 3b, and 1c, and that also equals to 0. And then the last one is 1/4, so 0.25, 1/2, so 0.5, and 1c, and that equals negative 12.5. And now I can solve the equation and I can find what my unknowns were, A, B, and C. We can see that A, the first one is 2, Y is negative 2, which isn't Y. I need to make sure that I label that as B, and then the last one, C, is negative 12. And once we have those values, we're then asked to, in part C, write down the equation of the axis of symmetry. So the axis of symmetry is just this line here that I did earlier. And this line would be x equals 0.5. So you're just writing your answer in here as x equals 0.5, and that would be your full answer. So in terms of the method marks, you have 5 marks for that middle section. So 2 of them are method marks for substituting in your coordinates, and then you have 1 answer for each of these. So that is a really good question to then get right. You just have to type those equations in and it's worth 5 marks. And then the last one is 1 mark for the answer, which has to be written in the correct format of x equals, because it does ask for the equation of the axis of symmetry.